Hello, today I'm going to talk about the design of steel structures. The design of steel structure involves three elements which all have to be checked. One is to establish the loads that the structure has to support. The second is to establish a geometry for the structure. The third is to perform an analysis of the structure to assure that it is structurally adequate to support the loads and the equipment. ASCE 7 minimum design loads for buildings and other structures establishes 14 kind of loads. This includes things like snow loads, ice loads, and earthquake loads. The loads that we will look at in all of our projects are equipment loads, dead loads, live loads, and wind loads. The equipment loads we get from the equipment manufacturer, and it's usually just the weight of the equipment, including the weight of the water that the equipment might contain. But it also might include an allowance for the forces from moving parts in the equipment. Dead loads are just the weight of the structure itself, the beams, the columns, the grating, and the concrete deck. Live loads are an allowance for the weight of people and materials that occupy the structure. Wind loads are the most complicated. Wind loads are proportional to the area impacted by the wind, and they're proportional to the square of the velocity of the wind. Since 1988, ASCE 7 has redefined the design wind load for the Houston Ship Channel area from 90 miles per hour to 140 miles per hour. This represents a 142% increase in the basic wind pressures for design. With the values of these several loads established, the code then requires that we look at various combinations of loads. Why not just apply all the loads and call it conservative? Here's an example. When we design a foundation for a vertical tank, we design the concrete foundation to support the weight of the tank full of water. When we check the anchor bolts, which will hold the tank in place against the wind, we check that without the weight of the water, which would help to hold the tank in place. With our loads checked, we can now talk about the design of the geometry of the structure. The piping designers will work out an alignment between the vessels, equipment, and major piping, which allows for the connections called for by process flow. At this time, they'll usually do a preliminary model of the structure to assure that their piping alignment clears the structure. If they haven't done that, then the structural designers will take over. The structural designers will also go to the field and make measurements to confirm the clearances that we think we have, and they'll check the drawings of existing equipment and structures and check the location of underground piping. At this time, we will have made preliminary choices of member sizes for the structure. With a preliminary structure geometry and design and loads defined, it's time to do an analysis. The analysis can be done by one of several methods, and the engineer will choose the method which is the most economical, the most expedient, and the most practical. For a small structure, like an access platform to a valve, we'll rely on experience with previous designs to avoid doing unnecessary calculations and charging unnecessary time to the job. For a more complicated structure with more complicated geometry or heavier loads, the engineer might elect to do manual calculations, and those manual calculations will involve the use of spreadsheets and will refer to the beam selection charts and the column selection tables of the steel construction manual. For an even more complicated structure with more complicated geometry, a larger number of members, and heavier loads, the structural engineer might decide to use a structural analysis software package. The structural analysis software packages have the requirements of the steel construction manual built into them. In doing the structural analysis, we'll determine whether the preliminary member sizes are adequate or if the member sizes need to be adjusted. With the geometry established and the member sizes confirmed through analysis, we'll embody all this information into construction drawings, which will be issued to the client. The client will review the drawings, and there will often be a model review meeting in which members of the maintenance and operations teams can make suggestions regarding widened access to equipment or increased spaces for maintenance. Once we've incorporated the client's comments into the drawings will be issued for construction. Nassau EPC has 2 licensed PEs who can perform the structural analysis and oversee the design of structures. Thank you for listening to this brief overview of steel structure design.